Welcome back. I'm Chris Moore with HVAC Pro Blog, and this week I'm excited to share part 2 of a 3-part series on zoning system diagnostics. In part 2, we're going to cover controlling relative humidity. This is a recorded webinar I provided my Patreon members 1 year ago. Without further ado, let's talk about %RH. So, first thing I want to point out here is the optimal relative humidity that we want to maintain in a home across the United States ideally would be 50% relative humidity. Now there are some parts of the country, let's say in the southeast, right, that's very humid, in Miami let's say, where they can design around 55%, but if you creep up to 60%, that's what I'm going to say is the max. You can still be comfortable if you cool the air much lower if it's actually a little bit more humid in the space. If it's really difficult and expensive to try to maintain 50%, then up to 60% is fine, okay? But think about how that system is going to maintain that humidity. Obviously, when we're talking about dehumidifying, we need a whole house dehumidifier in most applications, let's say in the Northeast. If you have a basement that's below grade, you need a dehumidifier, probably a whole house dehumidifier. You're not going to be able to keep up with those little space ones, all right? This is really important because if you're not comfortable in some part of the home, it may not be because of the HVAC system and the comfort in that particular room may not be because of the balancing of the system. It might be designed right, but we're not controlling the amount of moisture coming into the house. We're only controlling and trying to pull back what's in the home already. So if we can actually remove a bunch of moisture using a whole house dehumidifier, which is typically sized to 85% of the latent gains of the home, then it really helps our air conditioner that's designed to maintain comfort in the space for humans, right? And then of course, we want a minimum relative humidity in the wintertime too, and you can see this image on the right hand side is a bypassed humidifier. Keep in mind, that's bypassing air if that damper is open in the heating season, which could wreak havoc when you talk about barometric style bypass dampers, right? So really important, how the system is going to be operating in the heating season is how you should be setting that up. It may operate differently in the cooling season. Is anybody adjusting that barometric damper? I highly doubt it, right? So really important to note how the system is installed. Now, why up to 60%? That's because once we get above 60%, it makes a great spot for moisture to actually settle on sheetrock and other home surfaces inside ductwork, and that's when mold and mildew starts to grow. So that's why we want to keep it below 60%. Now 60% might be comfortable if it's 68 or 70 degrees in the house. It's not going to be comfortable if it's 78 in the house, right? So that's why people keep turning it down, and then you start to reduce the the dew point of the air, right? And if the device that you have, let's say your ductwork, is below the dew point of the air, that's when we get condensation, and that's when mold and mildew starts to grow, all right? So that's why the target is really important, I think, for you guys to understand why, so you can explain it to a homeowner on the front end during the sales process, right? Why you're not comfortable because it's 60% relative humidity in your space, and the system needs to be redesigned, or why zoning isn't gonna fix the problem, and why we need a whole house dehumidifier, for example, okay? So moisture gains really need to be minimized, and the number one way to minimize it is actually to reduce the home infiltration. So this can easily be done by getting your house air sealed. Most retrofit companies that do energy audits and stuff for local programs, like in Massachusetts we have MassSave, NYSERDA in New York. Every state seems to have some utility rebate program, and a component of that is weatherization of homes. And obviously, it doesn't matter if we're losing heat in the winter or we're pulling in moisture in the summertime. Air sealing is really going to help minimize those problems. Another one is sealing all ductwork and doing it correctly. Just because you have flex duct doesn't mean it's air sealed correctly, right? So you can see this is an old image where you have like a hose clamp style connection. Obviously, most people use duct ties here. They'll seal that, but you should also paint that, right? So you should use some air sealant on there, duct sealant on there, and then pull that that insulation back over the connection and seal that to the duct as well, right? Because obviously if any airflow is moving through the insulation, it's not really effective. But the number one place that you're going to find home leakage is really around the foundation, and then of course attics, right? So all the penetrations in attics. So that's where most home weatherization companies actually concentrate their efforts in air sealing, and you should always air seal before you insulate. Just like with ductwork, you should always air seal the ductwork before you insulate the ductwork. All right, so let's talk about if you don't have good combustion makeup air or balancing of the home, what can happen to it, right? So let's say we have a dryer or a gas appliance in the space, and we're taking all that air from the space and we're then exhausting it outside. The air actually that's coming back into the space needs to come from somewhere, and it's typically most likely going to come from holes, electrical sockets, plumbing penetrations, you name it. It's coming from somewhere in the space. What we don't want it coming from, oh man, is the natural vent 40-gallon hot water heater, right? Or your steam boiler. We don't want that coming from the chimney, because if that's operating at the same time as your dryer, you could be pulling combustion materials back into space. So please make sure you do a combustion appliance zone test every time you address the home. If you're sealing up ductwork, you're adding ductwork, adding returns because you're pulling a negative pressure from some space, make sure you test the combustion appliance zone and we don't hurt anybody in the house. Seems elementary here. If you've never done it before, just head over to bpi.org. There's a great step-by-step process over there, all right? Now, what's really important here is if we have a negative pressure in a space, so as an example, the second floor of a Cape style or a colonial style home, I see a lot of central returns in hallways. If we take all of the air for a 2 or 3 ton system, let's say, from the center hallway, and we just rely on undercut doors or something to pull air back from all of the bedrooms all the way around, it is very easy to pull a negative pressure in the hallway if anybody close any of those doors, right? Because we're supplying all the supply air to those rooms. When a door closes, we are now going to pull more air back from that space than what's connected to it. Now that air has to come from somewhere, and it could come from the fireplace, it could come from the kitchen, could come from anywhere, right? So very important that if we have a large negative pressure situation, that we actually have makeup air in the space. And you see this a lot with boilers, especially oil boilers or oil furnaces. Every time that burner kicks on, because it uses so much combustion air, we actually have things that like a fan in the can. It takes actually air from outside and it turns on anytime the burner turns on, right? That's makeup air. Or if you have some crazy kitchen hood and it's over 400 CFM, that's actually exhausting from the space, you should be adding air into that space, especially in a tight, like net zero style home. Makeup air is extremely important. Now, not ventilation air. Ventilation air is different, and we need to control ventilation air. And the easiest way to do that is with an HRV or an ERV, right? We still need to control that humidity. We can't just dump a bunch of humidity in the space every time the kitchen hood turns on. And no wonders these homes may not be comfortable if you're not treating that air, right? Adding zoning to that sort of system to the kitchen is not going to fix the problem. Treating the humidity that's being dumped into the space is what's going to fix the problem, okay? Obviously, sizing of cooling equipment is impacted by the makeup air that goes into the home. You need to account for that in the manual J load calculation. And then, of course, believe it or not, how you cycle the blower fan with this makeup air can actually impact the load, okay? So really important that these aspects are identified in the load calculation, because it then impacts the sizing of the equipment on the equipment selection and the sizing of the ductwork that goes to the space before you actually add zoning to the space or to the duct system. All right, moisture gains, right? So just to continue on this, how does moisture get into the house? A number one way I see is AC only systems up in an attic. You can actually add a ton of moisture to the space if you don't close cooling only ducts in the summertime. I'm sorry, in the wintertime. So obviously in the wintertime, you want to close those ducts. And an open return grill, like what's pictured here, is always tough to do. I see people pull filters out, they'll put trash bags around them and put the filter back in. That's one way to do it. A lot of people do seal these off with some duct register tape. You can get them and it doesn't peel the paint off. I used to use that a lot when I did duct testing in the past. Also, there's dampers that you can install right off that takeoff. Obviously, you want to make sure it's open in the operating season in the summertime, and then close it in the winter, right? Another way to control that moisture is obviously installing a dehumidifier if you have a moisture issue in just one part of your home, right? But keep in mind, dehumidifiers, because you're moving air out, if you're not venting it to outside, you actually will heat the space and it's gonna fight your air conditioner, okay? Obviously, making sure the refrigerant charge and the airflow is right. Now this sounds elementary, but obviously if you're undercharged or your airflow is too high, you're not gonna be able to remove the moisture at the coil and you're just gonna keep circulating that. And if you keep the fan on, which a lot of people do to try to cut down the temperature differences across rooms when it's not balanced or you have a zoning issue, you're never going to be able to remove the moisture from the air, because when the air conditioner cycles off, the fan then blows all that moisture back into the air. So you need to have that blower cycle off for all that water to drain off the coil and down that 3/4 inch drain or larger, right? Make sure that drain's clear, so that way that pan doesn't fill up and you don't blow all that moisture back into the air. It'll evaporate right back into it. And make sure that the coils and filters are clean. Now, so that's pretty obvious. You got to maintain the system, but if you're having a comfort problem in the space, these are some of the obvious things that need to be addressed first before you implement zoning. So what did you think? Did you like part 2 of this 3-part series on zoning system diagnostics? If you did, be sure to come back next week where we cover things like bypass damper issues and damper retrofit and evaluations. If you like this video and you want to get them 1 year in advance, head over to my Patreon page where you can subscribe for as little as $8 a month. That will give you access to the last 24 written blogs and the last 12 monthly recorded webinars. Thanks again for joining me this week at HVAC Pro Blog, where we provide advice for residential system design, quality installation, and system diagnosis. I'll see you soon.